Hi, welcome to Mat100, and we are going to discuss section 4.14.2, a ratio proportion applications. So, what is a ratio? A ratio is a comparison of two things, and usually they are like things, two like things. It's very simple. It's just basically a fraction, huh? And we're going to compare maybe two things, like we could compare, let's say, the diameter of two pulleys. So the diameter of pulley A would be, say, 5 inches, and the diameter of pulley B is 10 inches. We can also take a ratio and reduce it, 1/2. So that's basically all a ratio is. It's basically a fancy name for a fraction, comparison of two things. When we put two, sorry, I'm looking away, I'm trying to find something. If we try to put two ratios together, we get what we call a proportion. So a proportion is putting, when we compare two ratios, we put them together, and then we get a proportion. Such as, so it's a comparison of two ratios. That's basically what it is. So let's suppose we have a ratio, and we're just going to do it in abstract terms, and I give you some samples. A is to B as C is to D. We have these two two ratios, and we compare them. That's called a proportion. To solve a proportion, we're going to use something called the cross product rule. What we're going to do is multiply the two numbers that are down. These are called the extremes, and we're going to multiply these two extremes together, A times D. We can write it like that, AD. And then we're going to multiply the two other diagonal, which are called the means, which is B times C, BC. So the product of the extremes, A times D, is equal to the product of the means, B times C. Let me give you one that's pretty basic that you can see. Suppose we had 1/2 and it's equal to 5/10. So if we multiply the extremes coming down, we get 1 times 10, which is 10. And if we multiply the means coming up, we get 2 times 5, which is 10. So we prove it's a true proportion. And if it's a true proportion, both sides have to be the same. But we're actually going to try to solve some proportions, and we're going to try to do it real easy. We're not going to knock ourselves out. A couple of different ways you could do it. But let's try this one. We have x is to 4 as 12 is to 16, and you can follow along in your book if you have it. This is on page 187. So to solve this, what we do, I'm going to show you the long way, and I'll show you a shortcut. We're going to multiply x times 16, 16x, the product of the extremes. And then we're going to do the product of the means, 48. And then we have those two multiplied. Whatever number is in front of the x term, we're going to divide by it. We're going to divide by the 16. So that would be 48 divided by 16. You could use your calculator. I happen to know that's 3. But 3 times 16 is 48. So I'm dividing 48 by 16, and this is the way we show divide. Okay, another way we could do that is x is equal to, find two numbers that are diagonal. Like here we have the 4 and the 16. We see those are diagonal. Multiply those numbers together and then divide by the number that's left over that you haven't used, the 16. So here we have 48 divided by 16, the same thing we had before, but not so fancy, and we get 3. Okay, let's try another one. Now, what's nice about this is it doesn't matter what letter you use, you don't always have to use an X. Here we're using an N, trying to find this number. And it doesn't always have to be in the first spot. It could be anywhere. Okay, how about N? What is N equal to? Find two numbers that are diagonal and multiply them. 6 times 10, 60, right? And divide by the number that's left, 15. And you could do this right on your calculator. Let's put it right there. 6 times 10 divided by 15. So you can do it all in one step. Bingo, 4. That's what we love about it. I'd say 70% of all math problems can be solved by proportion. If you heard of trigonometry, trigonometry is based all on proportion, a large portion of it. A lot of math is based on proportion, just common sense. A lot of math is proportional. Let me try again, a little bit harder one. 28 over 40 equals x over 100. Again, looks like kind of a hard problem. X is 28 times 100, multiply diagonally down, divide by the number that's left, 40. Let's see what we get. And you could reduce, you could do different things to this. I'm just going to multiply it the way it is. But you know, there's something. I'll show you a little shortcut too. 28 times 100 divided by 40. 70. And there's my answer. One thing I could have done on this is I could have marked off these two zeros, and I would have had 28 times 10. I could have divided 4 into 28 7 times and got 7 times 10 is 70 if you wanted to save a little bit of time. But for some people, that's, you know, gets all messy and complicated. So you can just go straight across. But if you're into like maybe trying to do a little faster, get rid of your zeros, then 4 into 28 is 7. This is gone, 7 times 10. So, you know, different ways. Here's one that's a little tougher. Let me try this, kind of a hard problem here. Let's see if I can find it. Let's try this one. How about 2.5 is to 3.5? We could say like this, as W is to 2. See, here the W is up here. Okay, so again, find two numbers that are diagonal. But instead of using 2.5, remember in the last lesson, what is a half equal to? 0.5. So we could take W, I would just start out with my variable, is equal to 2.5 times 2. This is another way of writing times. See, I kind of hit in there. And divide by 3.5. Again, a half is 0.5. So 2.5 times 2 divide by 3.5. And you could do this on any calculator, you know. You don't have to have the scientific. You can just use a cheapy calculator. save over time. Wow, this came out with a huge whole answer. Let me double check and make sure that's awfully big, but let me make sure. 2.5 times 2 divided by 3.5. Let me enter this a little bit differently and see, maybe I was thinking that this was 2/3. I don't know. It seemed like a big answer. 1.42857. Notice this looks like it's repeating. And I'm going to write it down again. I'm going to put this in parentheses. 2.5 divided by, excuse me. See, I can go back on this one. Go back. 2.5 times 2 divided by 3.5. Okay, well, I happen to know, and the answer was just this number right here, but I happen to know that 42857, 1.42857 is 1/7. So, kind of around that area. But I'd probably just leave this as a decimal and put a line over it showing it's repeating. You could leave it like that. Let's see if we did it with actual fractions. 2.5 times 2. Going to get an answer. Let's see, that's 5/2 times 2 is 5. And then I'm going to divide that by 3.5. Well, that's 5 divided by 2 times 3 is 6, plus 1 is 7/2. So that's 5 times 2/7. So that's 10/7. And then if I took my calculator and I took 10 and I divided by 7, you see, that's how I come up with that answer. So 10/7 is also an answer. So we could actually do this with fractions too. Maybe it takes a little longer, but that would be good practice. So there's some ideas. Now, let's try some little application problems. It says, on a construction job, concrete is mixed using a volume ratio of 1 part cement to 2.5 parts sand and 4 parts gravel. Now here we have 3 things. It's like, what's going on here? How much sand should be mixed with 3 cubic feet of cement? Oh, wow. So let's see. We want to know something about cement and sand. So even though they threw in gravel in here, we're not going to use that. Okay, so the way I would put this up, write this is, I'm going to put cement on the top, and I like to write that out. There's 1 part. And then I'm going to put sand on the bottom, over cement over sand. And this is going to be 2.5 equals. Now, what I want to know is how much sand. So I'm looking for sand on the bottom. Let's put an S for sand. And then on the top, I'm going to put how much cement, 3 cubic feet. So cement on the top, 1, 3, sand on the bottom, 2.5, and that's what we're trying to find. They kind of threw in the gravel, but we're not using it for this particular mix. So how do I solve that? Well, I multiply these 2, which is, let's make it fancy. We're looking for sand. If you want to write it out, you can. Sand is equal to 3 times 2.5. And then we're going to divide by the number that's left, which is 1, which is not really going to change anything. So this is going to be, clear this all out. 3 times, 3 times 2.5 divide by 1, but I'm not going to write that down because I know that's not going to change anything. 7.5. So what is that going to be? Parts sand. We want to label these. And so there's my answer. All right, Lefty Groove has a strikeout to walk ratio, and this is read as 5 to 12. Instead of writing as a fraction, we can use a colon. We could also write the word 5 to 12. 5 to 2. We can write this as with a colon or this way, or we could write it like this. All those mean the same thing, just different ways. If he has 52 strikeouts, how many walks has he given up? Okay, what does the 5 stand for? Strikeouts, 2 walks. So let's put symbol for strikeouts is a K. Let's put a 5, and the symbol for a walk, we'll put a W, is 2. 5 strikeouts. I like to put this in words down here. 5. We're going to put strikeouts over walks. Now I'm going to put the 52 strikeouts. I'm going to set that equal to 52 strikeouts, and this should tell me the number of walks. So W equals what? Diagonal, and then divide by the number that's left, 5. And that should give me my answer. 52 times 2 divide by 5. Here I did it separately, but that's okay. 20.8. So we're going to round this up because 8's kind of a big number. You can't have 8/10 of a walk. He's not in the middle of a pitch. So we would say 21. And if we want to show approximately, we make kind of wavy lines. That means approximately. 21, let's label it walks. Good. Okay, medication, TTQ, is available only in liquid form with a concentration of, this is read 12 milligrams per 5 milliliters. 120, what did I say, 12? 125 milligrams per 5 milliliters. How many milliliters should be given to a patient if 500 milligrams of TTQ is ordered? Okay, so right here is our ratio. Our ratio is 125 milligrams, and I just put the milligrams right there, over 5 milliliters. Now, the order that you were given was to fill a prescription of 500 milligrams. Maybe the doctor didn't know this was in liquid form. So now you got to convert it. Where should I put the 500 milligrams? Should I put it on top or on the bottom? See, here's the trick. So yes, I'm going to put it on the top. 500 milligrams go on the top. And we're trying to figure out how many milliliters, X amount of milliliters we have to mix up. So now we could cross multiply. The milliliters that we're looking for is equal to 500 times 5 divide by number that's left over, 125. And this should tell me how many milliliters to give to that patient. We don't want to give them 500. Seems a little bit high. Might kill them. Times 5 equals, this is going to be a matter of life and death. This one problem. 125 milliliters. ml. Let's double check our math here. 500 times 5 divide by 125. 20. See, that's why it's always good to double check your work. I thought the answer seemed kind of high, so I might have, even though I'm using the calculator, I might have given this patient the wrong dosage, and that could be terrible. So always double check your work. On a quiz or something, you're using a calculator. How hard is it to re-enter that one more time. And I don't know what I did wrong. I probably put in 25 or something instead of 125. But what's nice about this calculator is we can now see what we put in. And that's another reason why it's good to put it all in one step. Okay, so I've got one last one. We can also compare objects. And here we see a ratio. So we can compare the height to the base. Height, base. And you could write out the whole word, or you could abbreviate it. If you want to write out height and base, you could, or you just abbreviate. So the height is 10, and this mark means feet, and the base is 12 feet. Now, we're comparing it to this. This is okay as long as both of these are going to be, the 2 marks mean inches. So 4 would still be what? 4 would be the height, huh? And we're looking for the base. So let's cross multiply. Let's see, base is equal to 12 times 4 divided by 12. So let's put that in our calculator where we can see it. Okay, maybe over here. Clear this out. 12 times 4 wait a minute, divided by 10. Again, going too fast. 12 times 4 divided by 10. Yes, that did not sound right. Divide by 10. Here we go. 4.8. So that answer sounds kind of suspicious. 4.8 inches. So I'm going to look at my work again. 12 times 4 divided by 10. Yes, I have it set up right. 4.8 inches. So it doesn't hurt to double check it. As long as it's displayed, you're okay. But we want to double check our work and make sure we're doing it correctly. So I hope you enjoyed the video. Good luck to you on your assignments and your quizzes and all that stuff.